Okay, hi, how you doing? We're going to talk about how is it that I add polynomials together. And the thing that I have written over here again is PEMDAS, just to revert back to the idea of everything must follow an order of operations. So when I take a look at this particular problem, what I notice is that the first thing that comes to my mind is parentheses. And order of operations means I should definitely look inside those parentheses to see is there anything that I can do inside that parenthesis to create a simpler expression than what is already currently in there. So if I take a look at this first parenthesis, I have 4x squared plus 3x minus 5. The most important thing here that you want to know is that yes, this term here has an x, and yes, this term here has an x, but they aren't considered to be like terms. Because like terms means that the variable and their exponents match identically. And if I take a look at this term, okay, it has a 4 and it has an x, but the exponent is a 2. And if I take a look at this term, it has a 3 and it has an x. And when we were doing multiplication, that was a little bit different because multiplication does not hold the same properties that always addition has. So they have some similarities and properties, but not all the same. So this one here, the addition property here, doesn't allow me to combine this x with this x simply because they are not identical variables, which is what a like term is. So this expression I can't combine with anything, it's just what it is. So I have this parenthesis. So now I have to go to the next one. I take a look at the next parenthesis and I go, okay, I have negative 5x plus 2. There's nothing that I can do there. This term has an x and this one doesn't even, so I can't combine things that aren't identically looking the same, okay? And I'm talking about the variable there. This has a variable, that doesn't, so I can't even combine them because I only really am looking for those types of things. So now the problem is that I can't just drop parentheses without having some explanation as to why I'm getting rid of them. So it's not like I can just drop these and go, oh, they're done, blah, blah, blah. I have to have some sort of explanation as to why I can do it. Well, this group, there really is a 1 out in front, explaining that I have one of this group, this expression. And in front of this, after this plus sign, I also have a 1 in front of this group. So if I show that in there, okay, there's really one of this group and one of that group. So what that means here is that this is 1 times whatever that group is plus 1 times whatever that group is. And to remove things from parentheses, you need to use the distributive property. So in this case, okay, because they're both positives, I don't really have to do any real work besides drop the parenthesis or just imagine that they're not there. And that's simply because they're both positive. Because positive doesn't affect the sign, nor does it a 1. A 1 does not affect the value of anything. 1 times whatever you multiply by is what you multiplied by. And a positive won't affect the sign. So I really don't even have to bother thinking about anything. So when I do these particular problems, I'm just looking for, okay, do I have another x squared? Any other x squareds? No. So the amount of x squareds that I have here are 4x squared. And then I look up here and I go, okay, I've got 3x. Okay, so I have 3x, and then I've got a negative 5x. So you can think about it that way, or we can write this back out for some people and just write the statement out as plus. So plus the negative makes negative 5x. And then plus and plus makes that a plus 2. So all I did, what you notice, is really drop the parenthesis, and that plus sign went away. Okay? And I just put what was in here. So now I have 4x squared. So here we go. Nothing to combine it with. Now my like terms are the 3x and the negative 5x. And again, notice what I was talking about, that they were identical. The variable here is an x with an exponent of 1, and the variable here is x with an exponent of 1. So they are identical terms. And what determines what a term is the variable with the exponent, not the number. This 3 and this negative 5 do nothing more than allow me to stick those two numbers together with that variable. So there is still going to be an x here, okay? And this is a 4x squared if I have to write, sorry. So what does positive 3 and negative 5 make? It makes negative 2, so I write a minus 2. And then again, I have just two numbers here which are identical, okay, or like terms. They both don't have variables, so I can just add or subtract them like normal. So what does negative 5 plus 2 make? It makes negative 3. So that's the basic principle of adding. And what you want to get out of this is that you can mix all these things up, but if you have an addition sign with a 1 in front of a parenthesis, it really is just saying, okay, take that group as it is or what it is and just add it to this group's, whatever their expressions are, and combine your like terms. And that's how you add a polynomial. So I hope that it helps with whatever homework you're doing.